Now we're going to take a look at the lesson Equations with Cups and Chips. This lesson is day 1 of lesson 1 in Unit 3. When will you teach this lesson? We'll take a look at the big picture to find out. As you can see, this lesson is taught in both Math 7 and Math 7 Accelerated. The whole entire lesson should take 2 days. However, the activity that we're going to do in this video is used in day 1 of the 2 days. This is taught during week 8 in Math 7 and during week 7 in Math 7 Accelerated. When it comes to standards, helpful teacher tips, and presentation strategies, we're going to take a look at the scope and sequence for each lesson to find that out. First of all, the standards addressed for Math 7 will be numbers 8 and 9. For Math 7 Accelerated, there will be standards 17 and 18. And for our activity today, we're only going to need the integer chips and the small plastic cups. Also, all the presentation strategies are listed in the scope and sequence. But for this video, we're going to focus on just using the manipulatives for the activity. So the cups and chips that you'll need are actually teacher created, the cups are. And these are condiment cups. And you can see here that on the inside of each cup, we just wrote -X inside of every single one. And then we got these circular stickers. I call them yard sale stickers. And place those inside the cup on top of where the writing was for the -X. So that's going to keep the -X on the inside of the cup from getting smudged. Now let's get started on the examples. The examples that we're going to do are listed to the right. And here is one of the cups. So you can see the X and -X on the inside of the cup, and then this is on the bottom side of the cup where you can see the -X. So we're going to use our X cup to represent that unknown value in this first equation. Now, when it says +4, we're going to just use yellow chips. We're not going to have our plus sign in between the X and the chips because those 4 yellow chips represent +4. Likewise, on the other side, we're going to use our red chips to represent -5. So this is how we want the equation set up, and we want to walk around and look at the students, make sure that everyone is on the same page before we get started. Now this is a simple one-step equation, so really they're just learning to use the manipulatives. And so on this, I would just ask, what would we do to each side in order to solve the equation? And the response from that we're going to want to get will be to subtract 4. Now for this activity, we're not going to put a minus sign and then have 4 positives. By this time, we're hoping that our students are recognizing that when we combine the positive yellow 4 and -4, that those will represent the same thing. We're going to combine those and that those are going to cancel out and make those 0 pairs, similar to how they did when the chips are down, which was done in Unit 1. Okay, next, I want to remember that whatever I do to one side, I need to do to the other. So I'm going to place these 4 chips over on the right-hand side of the equation as well. So you can see that whatever I do to one side of the equation, I've done to the other. Now what's great about this is we're going to see that the chips over here on this side all make out 0 pairs. So all these are going to cancel out and they're going to go away. We're going to bring our X over a little bit here. And then we're going to look to see what can we do with the chips on the right-hand side. Since all of these chips are all red, we're just going to combine those together. So we know that our X value for this problem is -9. Some teachers like the idea of once I collect my chips, if I take them all and place them inside the cup, so then the kids know that the answer is -9. You can choose to do that or not to do that. It's your choice. All right, so let's look at the next equation. You can see to the right, the second equation is going to be 2x plus 6 is equal to 12. So for this time, I need 2 cups. And sometimes teachers will ask about, do I place them inside of each other? But we really want those to be separate so we can identify them here shortly. Okay, next. So I have 2x plus 6. And you all know that I'm going to represent that plus 6 with 6 yellow chips. So I'm going to place those over here. So on the left-hand side, I now have 2x plus 6 represented. And on the right, 12. 1, 2, 4, 6, 8, 10, and 12. So with this, as you walk around, you want to ask kids, can you represent this problem with your manipulatives? And so this is what you're going to be looking for. The 2 x's on the left-hand side, 6 positives on the left-hand side with those 2 x's, an equal sign in the middle, and to the right, positive 12. Now, once again, we want to ask the question, what do we need to do in order to make this 0 pairs, in order to make this cancel out? So these will go away because my overall goal is to figure out what is x. And as long as there's something over there with the x, I'm never going to be able to figure out what that is. So when we take a look at this, I see that I have 6 yellows. So in order to make those 0 pairs, in order to make those go away, cancel out, I'm going to need 6 reds or -6 in order to make that happen. On the right, whatever I do to one side, I want to do to the other. And I'm going to move these around just a little bit so that it works a little better with what I got. There we are. So whatever I do to one side, I do to the other. Now we can tell that these 0 pairs are going to go away. I'm going to pull them down and out of the way. What I'm left with on the left-hand side is 2x. On the right-hand side, now I have some things that need to be canceled out. On the last one, everything was the same color, so I just combined. On this, though, I got to put in the work and take away those 0 pairs. So I'm going to remove those one at a time. Some of your kids may be able to just pull 6 and 6 right from the beginning, and that's fine too. Now, what I'm left with here is 2x is equal to 6. And once again, I don't care what 2x is. I want to know just what x is. And so what this means is that when I group my chips into 2 equal parts, then I'm going to know what's the value of each part. So looking at these, if I figure out how I can separate them into 2 equal parts. So when I separate 6 into 2 equal parts, I get 3 for each cup, which lets me know that x is equal to 3. And once again, we could place those chips in the cup if we liked. All right. Now, one thing I really like about the cups and chips is that it lends itself to being able to take a look at the problem and also writing it down and converting it onto paper. So we can transition using cups and chips from this concrete example to an abstract. So we can actually bridge these two together. So let's take a look at the next example, number 3, which you can see is 3x minus 5 is equal to 7. So we'll start with our 3 x's. Here's my 3 x's. Scoot them up a little bit. Okay. And then I need a negative or minus 5 or negative 5. So I'm going to place those right here. So all that is what I need for the left-hand side of this equation. And now the right-hand side. So on the right-hand side, it's positive 7. So I will place 7 chips, 7 yellow chips on the right-hand side. Okay, so for this, what I'm going to do is as we go, first you want them to get comfortable with just using the manipulatives, but now as we go, I'm actually going to write the steps in order to solve. Okay, so let's take a look. My first thing I would do, I see that minus 5 there. I want to cancel and get rid of this stuff right here with the 3x. I want to get rid of that. Now that's 5 negative red, so I'm going to need 5, and I'm going to just group these a little different real quick. There we go. That gives me positive 5 to cancel out the 5 negatives on the left. And whatever I do to one side, I have to do to the other. So here is 5 more here on the right. Now at this point, what I could do is I could show my students where I can actually, this converts over to my equation. So I put positive 5, or I added 5 to both sides. Okay, now, so I can place that there and they can see that and where that's coming from. My next step is that I'm going to pull these out because these all make 0 pairs. There's 5 red, there's 5 yellow. We're going to pull these away. And what I have now, what I have left now, is I have 3x equals, and when I combine all these together, I end up with 12. Okay, now, we can show them those went away, the 5s cancel each other out, and what I now have left in my equation is 3x, and then 7 plus 5 gives me 12. So they can see exactly where every step is coming from. Next, I need to figure out, once again, I don't care how many 3x gives me, I want to know what 1x is. Since I have 3 cups, that means I have 3 groups that I need to figure out how much would be in each group. So you can do this one of 2 ways. We can go over here and we can count them off. One goes here, one goes here, one goes here. Another one goes there, another one goes there, another one goes there. Another one comes here, another one goes there, another one goes there. And so you see that I have equally distributed, and then I have 3 equal groups. And when I ask myself how many is in each group, or how much does each x represent, each x would represent a total of, move those up just a little, 4 chips. So x is equal, we divided them each into 3 groups, and so x is equal to 4. One of those cups would house 4 chips. Okay, so let's take a look at our next example. This one is a little different. Take a look at it while I'm getting set up so you can see what is different about this example. Okay, if you said that my x is negative, you are correct. And so when I go to build this, I want to make sure, remember when we designed our cups, we have negative x on the bottom. So when I go to set this up, I'm actually going to set this up with my cups upside down. So I will show this with negative 3x, and you can see how that's represented. Okay, next I want negative 1 or minus 1, so there that is. And negative 10. So I have 2, 4, 6, 8, 10. So here I have this entire equation represented for example 4. Okay, so we're going to drive back to the inverse or the opposite, getting rid of what's over there, the variable, so I can isolate the variable and figure out what it's equal to. So what's going to cancel out this red chip? This negative 1 is going to be a positive 1. And whatever I do to one side, I do to the other. And for those students who like to correlate and make this correspond, we can write that on their paper. By the way, this is also a great thing to do if they're struggling with an equation. You can have them go build it, and then they can see it concretely. So this will go away. These cancel out, and I cancel them out by dragging them off of the table. And then my negative 3x is still there, which you can see that, equals, and then over here when I take a look, I can't ever have 2 colors left. So anything when I have one of each, I'm going to make that a zero pair. These two cancel each other out, and I can see what's left. And when I count those up, I'm left with -9. All right, so what's the next step? What's the next thing we're going to try? Okay, so what we need to do is we need to put these in 3 equal groups because I have 3 cups that they need to go into. Now, I will say when it comes to solving equations and showing your work, this is going to be a little different than usual. Because at this point, typically we would have them divide by that -3. And with cups and chips, this is when they're just learning. Okay, so we're still working on breaking them into groups, and this is just a visual activity. So you may or may not want to use a negative for this example. All right, but let's take a look here. So once again, I got to break these apart into 3 equal groups. So here's 1 group, 2 groups, 3 groups, and I just keep on divvying them out until I can see that there are 3 reds in each group. Now what this tells me is that I have divided it into 3 groups, so I'm going to write that down. And what it tells me is that each one of the negative cups, each one of the negative x's is equal to a -3. However, we can't stop there. Okay, we want to know what x is. And so what we're going to do is we're actually going to take the chips, the cup, and we are going to flip our cup. The thing is, when you flip a cup, you are you can't just leave the red chips alone. You can't flip the cup and not flip the chips. So we have to do the same thing to both sides. And then what they'll find out later, let's flip these over. That a positive x, if negative x is equal to -3, then positive x is equal to +3. And later on, they can find out about dividing that by -1, or probably more than likely, they're just going to divide by that -3 to begin with. So this is one of those logic things that you just have a discussion about. If negative x equals -3, then what does positive x equal? And then they can come up with that +3. All right, so for this last one, we're going to take a look. We have 2x plus 1 is equal to 10. And those of you kind of playing it out in your head already know why I chose this one, because, well, we'll talk about it in just a minute. So 2x and plus 1. So there's my left-hand side. And over here on the right equals 10, 2, 4, 6, 8, and 10. Okay. Move these up just a smidge. Now, we go back to our original question of we want to get the variables by themselves. We need to do the inverse operation. What's going to cancel out that yellow chip? What's going to make that a 0 pair? And so what's going to make that a 0 pair is if I place a -1 or I subtract 1, but whatever I do to one side, I must do to both. So over here on my example, I'm going to subtract 1 from both sides. These cancel, so that means I've dragged them away. They go off the table. My 2x is still there. And then when I move this away, this cancels out this 1, so these 2 will go away, and I take a look at what I'm left with. And when I count those up, I get 9. Now, once again, I don't care what 2x is. I want to know what a single x is. And so here I go. I'm going to sort them into my groups. 1 for you, 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 1 for you. Oh, wait. So I don't have another one to share. So then you would have the discussion with your students as to how do I make this equal. Now, you don't want them cutting your chips in half, but you can have that discussion and they can come up with that solution. Okay? So when we divide both of these by 2, we place both of them in two groups, my answer ends up being 4.5 if we could actually cut the chip in half.